right, this short video will show you how to use a Punnett square to determine genotype and phenotype ratios of different matings. So let's just jump right into it. The first example we're going to use is a heterozygous person, right? A big dominant and a recessive allele mating with a homozygous recessive person. So again, homozygous recessive would be two small lowercase alleles, right? Two recessive alleles. So we write their genotypes here. Big T, little t for the person on the left. Over here, we have a little t for the person on the right. Then we looked at the possible combinations. So big T combining with little t right here. Here we have two little t's combining. Here we have a big T and little t combining. Here we have two little t's combining. So let's look at the genotype ratio first. And you can see here in this particular example, we have two offspring that are heterozygous, and we have two offspring that are homozygous recessive, and we have 0 offspring that are homozygous dominant. Now, there's different ways to write this, but for the purposes of my course, I like to use for the genotypes 3 different digits to really show the possible combinations. So again, we have 0 homozygous dominant, we have 2 heterozygous, and we have 2 homozygous recessive. Now, if we look at the phenotype, we have another similar ratio. The only 2 possible genotypes are dominant or recessive. The dominant phenotype, because they have at least one dominant allele, therefore they would have the dominant phenotype. So we have 2 dominant phenotypes, and then you can see here, these 2 individuals both have their homozygous recessive, so they only have those recessive alleles. Therefore, there would be 2 with the recessive alleles. Just to save a little time, I went ahead and started this one. Here we have 2 heterozygous individuals mating. So again, heterozygous means 1 dominant allele with an uppercase and 1 recessive allele with a lowercase. We wrote these on the sides and above on the Punnett square, and then we combined them. So here we see a big F and a big F come together. Here we can see a little f and a big F coming together. Here we can see another big F and little f coming together. And then here we can see a little f and a little f coming together. So again, looking at the genotypes first, how many of them are homozygous dominant, right? So that would just be this one individual is homozygous dominant. How many of them are heterozygous? We can see these 2 right here are heterozygous. How many of them are homozygous recessive? And we can see only this one is homozygous recessive, right? So there's our genotype frequency. Now the phenotype frequency is going to be a little different. We can see as far as the dominant phenotype, they could be homozygous dominant or heterozygous. Either way, they're going to have the dominant phenotype because they have at least 1 dominant allele. So we can see there are 3 dominant phenotypes, and only one of them has the recessive phenotype, right? Only one of them is homozygous recessive. Only one of them has only the small alleles, only the recessive alleles. Let's quickly move on to the next one. This one should be very quick and easy. These are 2 homozygous dominant individuals mating. So this one, there's a big R and a big R, right? This one's also a big R or a big R. Here, these 2 combine to be big R, big R. Same thing here. They combine to be big R, big R. Same thing here. Big R, and one last time, big R and big R come together right here. So again, genotype frequencies. How many of them are homozygous dominant, right? How many are big R? All 4 of them. And again, you could do this different ways, but for the purposes of my course, I like to use 3 digits. How many of them are heterozygous? 0. How many of them are homozygous recessive? And that would also be 0. So again, for the purposes of my course, you would write this as 4, 0, 0. Phenotypic ratio is also very simple, right? How many of them are going to have the dominant phenotype? All 4, right? How many of them are going to have the recessive phenotype? 0. Nice and easy. Let's quickly move on to the next one. Here we have a homozygous dominant mating with a homozygous recessive. Another way to say that is, if we were using examples of plants, right, we'd say a purebred, purple flower versus a purebred white flower, whatever the case may be. But either way, we're looking again at homozygous dominant. So 2 dominant alleles versus or mating with a homozygous recessive two recessive alleles. So we'll write these here, right? Homozygous dominant for the one individual, homozygous recessive for the other individual. We bring them together. We have big Q, little q. We have big Q, little q. We have big Q, little q. And then once again, another big Q, little q. So here we go again. Let's look at the genotype ratio first. How many of them are homozygous dominant? 0, right? None of them are big Q, big Q. So we will write 0. How many of them are heterozygous? All 4, right? All 4 of them are big Q, little q. How many of them are homozygous recessive? And again, there are none, right? There are 0 that are little q, little q. So we would write 0. And again, this is how I want you to do it in my course. Phenotype ratio. How many of them are dominant? You can see here that all 4 would be dominant because they have that at least one of that dominant allele, right? So as long as you have one dominant allele, you're going to have the dominant phenotype. How many of them are recessive? 0, right? Because none of them are homozygous recessive. Let's move on to another scenario. Here, this one's going to be also very quick and easy. We have 2 homozygous recessive individuals mating. So a little b for one person, a little b for the other. A little b and a little b come together for this one. A little b and a little b come together for this one. A little b and a little b come together for this one. And then finally, again, a little b and a little b come together for this one. So again, genotype ratios. How many of them are homozygous dominant, right? How many of them are big B, big B? 0. How many of them are heterozygous? In other words, how many of them are big B, little b? 0. How many of them are homozygous recessive? In other words, little b, little b? All 4. Phenotype ratio. How many of them have the dominant phenotype? 0, right? Not one of them has a dominant allele. How many of them have the recessive phenotype? All 4. All right. And then this is the last possible outcome here, or the last example, I should say. Here we have a homozygous dominant person mating with a homozygous recessive person. And you know what? Actually, I already did that one up here. So this one is actually just one more review, just using different letters. Again, we have big D, right? For this one person on the left. We have little d for this other one. We bring them together, big D, little d. Again, big D, little d. Here we have big D, little d. And then again, big D, little d. So again, genotypes, 0 of them are homozygous dominant, right? There's no big D, big Ds. All 4 are heterozygotes, right? So all 4 of them are big D, little d, and 0 of them are homozygous recessive. 0 of them have little d, little d. Phenotype ratios, again, they all have at least one dominant allele. Therefore, we have 4 dominant phenotypes and 0 recessive phenotypes. And that's it. With these examples, you should be able to do anything you want. I do want to point one thing out because I've received this question before. Sometimes students ask, does the order matter? And I'll show you what I mean by looking at some of these. Okay, so let's take a look at these. Let's redo these. So if you remember, both of these and these squares were big F, little f, right? Big F, little f. One student has asked before, well, all right, if we're combining a little f with a big F, right? Little f, big F, as opposed to big F, little f, does that matter? No, it doesn't, right? But in this case, we would do, again, big F first and little f second. It doesn't matter. So again, to make sure you can read this, big F, little f is the same as little f, big F, right? It does not matter. And that's it. As usual, if you have any questions, let me know. I'm more than happy to help. You do not have to go at this alone.